looking at the top of page 2 here, we've got the questions 3 and then we got question 4, so they should go nice and quick. It says Mad here is analyzing the scatter plot shown below. She determines that the data in the scatter plot have no correlation because as the x increase, the corresponding y values do not increase. Is she correct? Explain your reasoning. So when you look at this data, if I was going to fit a line to this data, I would go something like this. So I feel pretty strongly about this being a linear type relationship. There's not like a weird curve to it. It's not like all the data points are going to be right on that line, but it's still linear because the points are surrounding that line there. So she is saying that there's no correlation. There's definitely a negative correlation here. As the x values are getting bigger, you can see that the y values are getting smaller. So there's a correlation. It's just a negative correlation. And a lot of the problems that we saw, like in the book, were a positive correlation, whereas x went up, y went up. But this is a negative correlation. So is she correct? We're going to go ahead and say no. There's a negative correlation. And the reason there's a negative correlation is because the y values are getting smaller as the x values get bigger. So I suppose we could write that here. Explain your reasoning. I think this is good. There's a negative correlation. Okay, and then number 4. Determine whether the points in the scatter plot have a positive correlation, a negative correlation, or no correlation. Then determine which R value is most accurate and explain your reasoning. So if we had to put a line on this, I would definitely have it going this direction this time. So something like that. Usually when I'm trying to fit a line and I'm taking a guess, I would put about half the points above and about half the points below that line. So it might look something like that. But you can see here that this line has a positive slope, meaning it's a positive correlation. So I'm going to cross off the negative ones here. And it says to say whether it has a positive, negative, or no correlation. So there's a positive correlation. Then determine which R value is most accurate. So this R value here is almost 0. So because it's almost 0, that means that there would be no correlation. So this one is about no correlation, or close to no correlation. Where this one is 0.8, which is much closer to 1. So that means that the data is going to be pretty close to around a line. And this here, the data is kind of in this oval shape here. If you have the data and it's in like an oval shape where the line's pretty close to all of those, it's going to be fairly strong. This isn't like our 0.99s that we saw a lot of in class where the data is super, super close. But this is still clearly positive. We're not going, oh, I don't know, maybe there's no correlation. So we're going to choose this one for our answer. So we can say positive correlation, so R is positive. And it's fairly strong, which is why we're picking 0.8. This would be like super, super weak where we might think there's no correlation at all. Moderately strong or moderate to strong or fairly strong, any of those wordings would be okay. There we go.